Well, welcome. In this video, we're going to be starting off where we left off yesterday. And so we're going to finish our notes, and this part of the lesson is going to be where we combine functions and their inverses. So let's start by reviewing what we summarized yesterday. So this is, remember when we deal with the inverse cosine of a value, and we're trying to figure out what theta is in that case. We're looking for a radian measure between 0 and pi. So for inverse cosine, remember we're only going to have one answer, and we're just looking for when is that one answer going to be between 0 or pi. Where if it's the inverse sine or the inverse tangent, we're focusing on finding the values between negative pi over 2 and pi over 2. So again, for these, there's only going to be a single answer, and to figure out that single answer, it's between negative pi over 2 and pi over 2. Now I included this little illustration here to remind you that anything that's in quadrant 4, we're not looking for the value if we were to go counterclockwise. We're looking for the value if we went clockwise, so it's going to be negative. So when we look at these 3 points over here, or even this one down here, it would be negative pi over 6, negative pi over 4, negative pi over 3, and then lastly negative pi over 2. So you want to keep that in mind when we're dealing with the inverse sine or the inverse tangent. So let's look at this first example in your notes. We have the inverse sine of the quantity sine of 5 pi over 6. So what we're going to do is work just like anything else in algebra. We're going to work our way, if there's multiple parentheses, we're going to work our way from the inside out. So we're going to start by finding the sine of 5 pi over 6. So it's not the inverse sine, it's just the sine of 5 pi over 6. That's just using the complete unit circle. So remember 5 pi over 6 is over here. Sine is a vertical distance, so this is our short vertical distance. So the sine of pi over 6 would be 1/2. So inside of parentheses there, we just found that value to be 1/2. Now we just need to find the inverse sine of 1/2. So sticking with where that value is on the unit circle, remember for the inverse sine, we're looking for values between negative pi over 2 and pi over 2. Well, this point where it's currently at is not in that interval. So we want to remember the sine. We flip that over the y-axis to get a value that's in the interval that we're looking for. So that spot is at pi over 6. So pretty simple. So when it talks about creating a triangle, really just means just referencing the unit circle is all that's talking about. At the very end of this lesson, the second half, when we're not doing values that are on the unit circle, that's when we're definitely going to want to create an actual triangle. We're going to skip this one in your notes because that's not on the unit circle. So let's look at these. I know it says guided practice, but we really haven't talked about much to be able to do all these on your own. So let's just do a couple of these together, and then I'm going to have you do a couple on your own. So let's look at this first one, number 19a. So it's asking us to find the sine of the inverse tangent of 1. Okay, so now the inverse tangent of 1. So remember the inverse tangent, we're focusing on between negative pi over 2 and pi over 2. Remember where the tangent is 1, that's in the middle. So that's at, and it's positive 1, so it's going to be the middle of quadrant 1. So that's at pi over 4 radians. And so now we just want to find, well, what's the sine of pi over 4 radians, which is at the same spot. So the sine at that value, that is going to be square root of 2 over 2. So that would be your answer for 19a. Let's do another one. Let's do the one below it. So 19c, where we have the inverse cosine of the cosine 7 pi over 4. So let's start with, I'll use a different color. Let's start with the cosine of 7 pi over 4. So we always start with the inside of parentheses. So 7 pi over 4, remember that's going to be down here in quadrant 4. So the cosine of 7 pi over 4, that's going to be a horizontal distance. It's in the middle. So that's a positive square root of 2 over 2. So now we want to find the inverse cosine of square root 2 over 2. So remember that's going to be the same as, ironically, this one up here. Because remember for the cosine, we're going to reflect it over the x-axis. So for the cosine, we're focusing on values between 0 and pi. So the answer that we were working with down here at 7 pi over 4, that's not within that range. So we want to reflect that over the x-axis to get a value that's within the range of between 0 and pi. So that brings us up there at pi over 4. Okay, regardless of how you feel right now, I still want you to try these two on your own. Now this is, remember yesterday at the end of our notes, we talked about arc cosine, arc tangent. Remember those are the same as, so arc cosine is the same as the inverse cosine. Arc tangent is the same as inverse tangent. So if you want to replace those with the inverse cosine and inverse tangent, you can. But I want you guys to try these two on your own. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. I have these on the next slide. Here we go. So looking at that first one, again, it looks kind of strange all at once. So let's make sure we understand it step by step. So what we did first is we focus on what's inside the parentheses. So the tangent to pi over 4 radians, pi over 4 is right here at 1. And so then we want to find the inverse cosine of that value, the inverse cosine of 1. Now remember, 1 is going to be, so that's a horizontal distance of positive 1. So that brings us down here. So horizontal distance of 1 would be there at 0 radians. So that would be your answer for 19b. For 19d, it's asking for the inverse tangent of the cosine of pi. So we start with the cosine of pi. So here's pi way over here. So the cosine at pi is -1. And so now we want to take the inverse tangent of -1. Now remember, inverse tangent, we're focusing on values between negative pi over 2 and pi over 2. So remember, it's negative down here. And so tangent of -1, that's in the middle down here. And so that's going to be, again, going this direction. It's going to be a negative rotation at negative pi over 4. So that would be your answer for 19D. Now it's up to you. If you want to keep going, you can keep going. Or if you want to pause the video and then jump into your assignment, numbers 16 through 30 are ones just like the ones we just did. So if you want to pause, get those done, and then work, and then watch the next part of the video to work on the second half, or if you just want to trudge forward, let's do that. All right, so for this one, this is not a value on the unit circle. So for these problems, we're definitely going to draw a triangle. Okay, so let's recall how we're going to do that. So first off, you want to figure out what quadrant it's going to be in. So for the inverse for the inverse cosecant, or just even referencing it as a cosecant, so remember that's the reciprocal for the sine function. In the sine function, the inverse sine is restricted to be between negative pi over 2, so the cosecant is restricted for the same to be in the same quadrants. So that tells me the triangle has to be in quadrant 1 or in quadrant 4. All right, so since we're dealing with a negative 13/5. Now remember, the cosecant's reciprocal of the sine function. The sine would be opposite over the hypotenuse. So this is referring to the hypotenuse of the opposite leg. Remember, when we draw our triangles, the hypotenuse is never negative. It's always positive. So again, the fact that we're dealing with a negative value means it's got to be down here in quadrant 4. So the negative value is going to be referring to the denominator there, the opposite leg. Because again, the hypotenuse will always be positive for these. All right, so now we have our triangle. So now we basically use this to create our triangle. And what we're trying to find is this. What is the cosine? Remember, the cosine is the adjacent over the hypotenuse. So we just want to find out, well, what's the adjacent leg over the hypotenuse? So in order to find that, remember this is theta. So we need to figure out that length here first. We need to find out what's A. So to use that, or to do that, we're going to use Pythagorean theorem. So it'll be a squared, negative 5 squared is 25, equals 13 squared, which is 169. And so now if we solve that, we would subtract 25 from both sides, and that would give me 144. If I take the square root of 144, I get 12. And that is a positive 12 because it's to the right of 0. Remember when we did these before? You always want to look to see if it should be positive or negative. So that'd be a positive 12. So now we could find the cosine. It's going to be the adjacent over the hypotenuse. Oops. So your answer would be 12/13. Let's try another one. This one's right below the previous one in your notes, so let's try this one. So we have the Tangent of the inverse cosine of negative 5/7. So again, negative 5/7, it's not on my unit circle. So I'm going to use this information to create my triangle. Okay, so let's think about this for a second. So the cosine, we're dealing with quadrants 1 and 2. It's a negative, so we know then that it's going to be over here in quadrant 2. So let's label the sides. So that tells me, remember, cosine is adjacent over the hypotenuse. So this time the negative is going to apply to the adjacent leg. So it's never, the negative never applies to the hypotenuse. So that negative 5, the hypotenuse is 7. Well, to find tangent, we need to know the opposite leg. I'll just call that B this time. So to find out what B is, we're going to use the Pythagorean theorem again. So we would have negative 5 squared, which would be 25, plus B squared equals 7 squared, which is 49. Well, if I subtract 25 from both sides, I get B squared is 24. So if I take the square root of both sides, now remember, technically it's plus or minus, but for this problem, since we're dealing with the y value, and here in quadrant 2, the y value is positive, it's going to be the positive value. Now I do want to simplify this. Remember, the square root of 24 is the same as the square root of 4 times the square root of 6, and square root of 4 is 2. Oops. So we're going to use this as 2 square root of 6. So then the tangent would equal the opposite over the adjacent. So 2 square root of 6 over negative 5, that would be your answer. All right, I want you guys to try the next two on your own. So now the guided practice problem, instead of doing the guided practice problem that you see first, I want you guys to do just these two instead. So you're going to find the cotangent of the cosecant of negative 13/12. So remember the cosecant, remember that would be the reciprocal of the sine function. So this would be the opposite. This would be the hypotenuse. It's negative. So remember, I'm just going to help you just with this one. So remember, it follows the same rules as the inverse of the sine function. So it's going to be in quadrants 1 or 4. Since it's negative, we know it's going to be in quadrant 4. So I want you guys to set up your triangle, label the sides, find the missing side, and then use that to find the cotangent. Then I want you to do 20B completely on your own. So pause the video and hit play when you're ready to check your answers. All right, let's see how you did. So again, if we want to find the cosecant, that's the opposite over the hypotenuse. When you draw your triangle, the opposite leg would be a negative 12, because again, the hypotenuse will always be positive. So then our opposite leg would be the one that'd be negative. And our hypotenuse again would be 13. So we use the Pythagorean theorem to find the missing side length. So our missing side length is 5. And then the cotangent is reciprocal of the tangent. Tangent is opposite over the adjacent. So the cotangent would be the adjacent over the opposite leg. So the adjacent leg is 5, the opposite leg is negative 12. So we can say 5 over negative 12 or negative 5/12 would be the same thing. 20B. So remember, the arc sine is the same as the inverse sine of 3/10. So we're going to use that to set up the triangle. So the is positive, so we know it's in quadrant 1. So the opposite leg would be 3, the hypotenuse would be 10. Use Pythagorean theorem, you get square root of 91. Square root of 91 can't simplify, so we'll just leave it as that. And then the cotangent, just like before, is the adjacent leg over the opposite leg. So the adjacent leg would be square root of 91. The hypotenuse, or the opposite leg would be 3. So it'd be square root of 91 over 3. All right. So now you can either do, if you already did 16 through 30 even, now you just want to work on numbers 32 through 42 evens. Otherwise, if you trudge through and watch both parts of this video, then you're just going to want to make sure you do 16 through 42 even. So good luck as you work on that assignment.